Assalamualaikum to everyone. My name is Karin Nukman, and in this video, I'm going to briefly present about my FYP project, which is titled Supply Chain Optimization on Blockchain. This project research is under the supervision of Dr. Azlin binti Ahmad. And let's get on with it. The presentation will consist of Chapter 1, which is the introduction, followed by Chapter 2 of literature review and Chapter 3 of research methodology, in which will lead to the completion of this project proposal. Introduction. Supply chain management is defined as the management of transport or flow of goods and services. It helps in planning and executing various supply chain activities of a particular organization to build up a net value of the organization. When forming the supply chain, decisions are made on the participants of intermediaries, transportation methods, and the choice of carriers and warehouses. The studied supply chain network consists of logistics of each product towards a specific customer. The logistics of products will have a chronological flow starting from its respective warehouses, destination ports, and towards the customer. The overall cost of each supply chain logistics is based on the summation of the warehouse cost with its respective transportation costs. In a single day, there will be thousands of logistics that needs to be observed. A critical analytic needs to be managed in order for the company to not waste its resources on inefficient supply chain management. A way of minimizing the cost of managing the flow of goods is via optimization. An optimization method can be implemented to the supply chain network to ensure the cost minimization of supply chain can be fully utilized. As such, an effective supply chain is a supply chain that can minimize the cost of managing its flow of goods. That to be said, the flow of goods should be recorded in an honest manner in order to attain logistics, safety, and sustainability. Blockchain is the solution to ensure that every logistics in the supply chain network can have its data to be more transparent, immutable, decentralized, and also secured, thus leading the target of having the flow of goods to be recorded in an honest manner. The problem identified in this project is that warehouses have their daily order limit, specific order stock, and also only support a particular set of customers. This might cause inefficiency in handling supply chain resources if careful decisions are not made. As such, it might lead up to missing the opportunity to attain minimized costs incurred in supply chain. Also, the current supply chain network is based on a centralized network, which is extremely vulnerable to information tampering. Information tampering can affect the traceability of the supply chain, be it whether there might be hackers that wants to disrupt the supply chain network, or even the company who governs the whole supply chain network wants to eliminate transparency of its logistics. Several research questions has been brought up, which are how to attain the most cost-effective supply chain logistics, how to retain the genuinity of supply chain logistics data, and what is the flow of the logistics of the supply chain network. Hence, these are the objectives for the research. The first objective is to produce a set of warehouses, shipping lanes, and couriers to use for the most cost-effective supply chain using optimization method. Next is to propose a blockchain network that is transparent, decentralized, and immutable for the supply chain network. And for the third one is to visualize the logistics of the supply chain network. The scope of the project will only cover the supply chain based on supply chain logistic problem by Tatiana Kalganova from Brunel University London. The optimization will only be conducted using parallel end colony optimization to find the objective function of cost-effective supply chain. And the blockchain environment will be implemented on the Hyperlogic framework. The significance of this project is that the optimized supply chain network can attain cost effectiveness, which leads to a cost minimization incurred for the company. Data of each logistic remains genuine and immutable as it initially appended to the blockchain network. The governance structure is transparent, ensuring that the supply chain is 100% safe and sustainable. Also, there will be a minimization of third-party intervention and enable a trustless network via decentralization. Now, let's proceed to the second chapter, which is literature review. In this phase, the literature review has been made for this project research is approximately about 33 research papers. The Venn diagram shown is how the literature review has been made. The first one, the scopes covered for the supply chains are history and evolution of supply chain, logistics and supply chain management, managing the sustainability of supply chain, and focuses on Industry 4.0 on supply chain. Next, the scope for optimizations are the type of optimization methods and the application of optimization methods. Next, followed by blockchain, studies has been made for the key concept of blockchain, blockchain functionality, hashing values and consensus protocol, smart contracts, SWOT analysis, and types of blockchain. Then, the merged concept of supply chain and optimization is using end colony optimization on supply chain, genetic algorithm on supply chain, and fuzzy optimization on supply chain. Then, followed by the concept of supply chain and blockchain, it is studied to find the initial problems with centralized supply chain performance dimension of blockchain, blockchain application in supply chain, focus of blockchain in supply chain, and the benefits of blockchain in supply chain. Then last but not least, the concept of optimization and blockchain. And colony optimization multi-scale demand in the response of bidding mechanism based off a blockchain network. Thus, with these all elements of literature merged together, the concept of supply chain optimization on blockchain arises. Proceeding to the third chapter, which is the research methodology, this phase is about the project's research phases and development concepts. The research will consist of several phases, which will be followed in chronological order of preliminary study, knowledge acquisition, data preparation, phase 1, phase 2, and visualization. Starting from the preliminary study until the end of phase 1, the focus is centered on achieving the first objective, which is to produce a set of warehouses, shipping lanes, and couriers to use for the most cost-effective supply chain using optimization method. For phase 2, it is focused on achieving the second objective, which is to propose a blockchain network that is transparent, decentralized, and immutable for the supply chain network. Lastly, the visualization is to fulfill the third objective, which is to visualize the logistics of the supply chain network. This is the timeline for the project research. The time frame shows that it starts at the first week of the semester, which is in the month of March 2021, until the last week of the following semester, which is on the third week of January 2022. Here, we have the dataset table for supply chain network. The dataset is about the supply chain logistics problem by Tatiana Kalganova from Brunel University, London, and we have 7 tables in the dataset. The first table is order list, which describes the list of orders. Then we have freight rates that describes all available couriers, the weight gaps for each lanes and rate associated. Then we have shipping lanes that refers to the courier transportation, mode service, level combination between the 2 shipping ports. Then we have plant ports that describes the allowed links between the warehouses and shipping ports in the real world. Then we have product per plant that lists all supported warehouse product combination. Then we have VMI customers that contains all edge cases where the warehouse is only allowed to support specific customers, while any other non-listed warehouse can supply to any customer. Now lastly, we have warehouse capacity list. Warehouse capacity is measured in the number of orders per day, and the warehouse cost specifies the cost associated in storing the product in a given warehouse measured in dollar per unit. The optimization method that will be implemented in this research is end colony optimization. Fundamentally, the algorithm acts in a meta-heuristic manner to search for the shortest path based on the pheromone deposits along the trail of artificial ants. And here is the pseudocode of the end colony optimization, which shows that the method is scoped down to implementing parallel end. And with this structure, it will allow pheromone sharing, thus it can converge faster. Of course, optimization requires objective functions. The objective function is the summation of all minimum values of warehouse costs and transportation costs. Now we have the flow of blockchain architecture that is based on the Hyperledger Fabric model. The environment of the network will be under a private blockchain network, which only the parties that are involved in the supply chain are eligible to join. Each logistic will have them undergo a transaction to invoke a smart contract among the validating entities of peers in order to attain consensus protocol. Then, lastly, the visualization phase emphasizes on creating a dashboard to visualize the logistics based on the optimized supply chain network, and each logistic route will be visualized. That is all from me. Thank you for watching.